The next presentation will be by Giulia Viggiani of Cambridge University on the project called Cenlimit, Centrifuge Modeling of Desaturation for Soil Liquefaction Mitigation. Giulia, go ahead.
Yes, I cannot share because Stefan is still sharing.
Okay, Stefan, please stop sharing.
Okay. Okay. Share. And hello.
Yeah.
Can you see my slides?
It's okay.
Okay, perfect. So, hello everybody. My name is Giulia Viggiani. I am from Cambridge University. And just I wanted to give a little mention to the fact that in the first round of proposals, we carried out two projects at Cambridge. One of them was this CTP-SSR that was about the cyclic and monotonic loading of pile rafts for onshore wind. And this is the team. It was a completely girls team. So we had two researchers and one intern and so on. And the project I'm going to talk about today is this Cenlimit, which was about the centrifuge modeling of desaturation for soil liquefaction mitigation. Now, although you've heard from Tom that Geolab is about the threats posed by extreme events to the critical infrastructure of Europe, and although not specifically focusing on the seismic hazard, still there are large areas of Southern Europe in which the seismic hazard is very relevant, particularly Turkey, Greece, Italy, and also Portugal. And of course, this is posing very important threats to our infrastructure. So this issue of potential soil liquefaction is a very relevant issue. So the objectives of the project were to assess the susceptibility to liquefaction of sandy deposits to liquefaction under realistic conditions of stress, seismic excitation and drainage, and to evaluate the performance of a mitigation measure, namely induced soil desaturation, to mitigate the risk of soil liquefaction. Now, this is wave-based in the sense that we were propagating S waves and P waves through a sample of soil while in flight on the centrifuge to see whether this induced desaturation was reducing the risk of liquefaction. Now, the team was essentially a Portuguese team. The leader was Cristiana Ferreira, who is a research associate professor at University of Porto, and she was assisted by two young researchers, one PhD student from Iran working in Portugal and one research associate from Colombia, and Professor Antonio Viana da Fonseca, who was the most senior member of the team. There was also one intern, Arianna Pucci, coming from Italy and joining the activities of the team during the project. Now, this is a very experienced team on this topic. They have both from the point of view of the interpretation of wave propagation methods, both P and S waves, and also the connections between wave velocity, degree of saturation, and risk of liquefaction. We tested two models. They were both created in Hostan sand at a relative density of 40%, and one of them was fully saturated using methyl cellulose solution. This not water. This is to render compatible from the scaling point of view the times in the seismic times, the dynamic times, and the times of consolidation. And the model were heavily instrumented. So you can see that there were three layers of bender elements. These were in the direction, they were propagating S waves and P waves in the direction orthogonal to the direction of shaking during the seismic events. And the models were fully instrumented using pore water pressure transducers, so miniature pore pressure transducers in the free field and close to the bender elements, and piezometric accelerometers. And obviously not shown in this slide, the strong box had a perspex window, so it was possible to do PIV, particle image velocimetry, during desaturation and shaking. And I'm always talking about this induced desaturation. This was created by injecting compressed air from the bottle of the sample in a number of ports. In this way, we were creating bubbles of air inside the soil, and the Bender elements would be in regions where the soil was not saturated anymore. And Bender element measurements of shear wave velocity and observations about excess pore water pressure during shaking were taken for the saturated and the desaturated models. Now, I don't know how many zillions traces of Bender elements were acquired during these tests, and I know from Christiane and her team that they are still busy with the results, with processing the results, but there is very strong evidence that this technique of induced desaturation was very effective in reducing surface settlements and reducing the risk of liquefaction. These are some slides from the actual experimental work. So this is the Bender element system, which included the function generator, an amplifier, and an oscilloscope. The Bender elements, as I told you, were propagating shear waves in the direction orthogonal to the direction of shaking, and the Bender elements were mounted on this perspex frame. You can see here the Bender elements protruding into the soil sample. So these were shear waves that were horizontally polarized and traveling horizontally. And here you can see model preparation. So as the sand is pluviated, the instruments are placed, accelerometers and pore water pressure transducers at the different heights in which they are supposed to be. Here you can see the two columns of the frame that are supporting the Bender elements. The top of the frame is only connected after the sand is being completely poured. This is more on instrument preparation, and this is a very happy Cristiana Ferreira once the first model was completely prepared. And here you can see the model once it's been placed on the shaking table. So there is this servo hydraulic shaker that can simulate all sorts of dynamic histories. And also you can see here that there are 3 LVDTs that are measuring the surface settlements of the sample directly, besides the PIV, which is done through this perspex window on the sample. Here is Fausto Molina, still in the centrifuge, but the model is absolutely ready to fly. This is a view from inside the Cambridge centrifuge. And I just wanted to mention that together with this, that were the main activities, the centrifuge testing, there were a set of parallel activities which took place in the geotechnical laboratories of the Cambridge National Research Facility for Infrastructure Sensing, which included sand characterization. So the Hostan sand that was used in the test was fully characterized in terms of particle morphology using a quick pick equipment that will look at the particles as they fall in front of a stroboscopic light, and there are pictures taken. So you can look at a number of morphological parameters, including sphericity, aspect ratio, and the likes. And resonant column torsion shear tests were carried out on the sand, both in dry conditions, in water saturated conditions, and saturated using the same methyl cellulose solution that was used for the actual tests, so as to have a direct measurements of small strain modulus and damping ratio from representative samples of the soil. Now, the sand characterization team was, the sand characterization was mostly carried out by the intern, Arianna Pucci, and by Rashid, the PhD student, who had a lot of fun using the equipment available in the new civil engineering laboratories at Cambridge. And just to finish, this was a really fun example of teamwork. I think that everybody got something out of it. Cambridge now has a system of Bender elements that can operate in flight, and we're using it over and over again, not just to look at desaturation effects, but also for other effects. And this was, you know, a first attempt at cooperating with this team from Porto, but it is pretty obvious that we're going to cooperate over and over again in the future, to say that these transnational access projects are often the opening way to put in contact different teams, different research teams from different countries in Europe, and pave the way to very, very meaningful collaborative work in the future. Thank you.
Okay, thank you, Giulia.